Hello, my dear friends, my dear students. Welcome back. Welcome back to your channel of learning mathematics. Good evening, all of you. So, finally, exercise 9.3 is done, finished. Now, we will continue with exercise 9.4. So, it's a very small exercise. So, at least last night, of course, I am actually very grateful to many of the students because that video was about for more than almost 1.5 hours, but many of you were patient enough, and then you gave us the encouragement to carry on. So last night was very successful, but tonight of course it's going to be a very small video only because the topic is quite small. It's just this infinite geometric series. How do we add the sum of an infinite geometric series? Like for example, so far we have had geometric progressions where the number of terms are limited, that's finite. So for example, like 3, 6, 12, 3, 6, 12, 24, and then it was far we have been doing geometric series like till the 20th term, where the number of terms are limited, the number of terms are already given to you. So according to that, we use the theorems that I gave you. But now here the difference would be, as you can see in the exercise also, the number of terms actually are not given to us. Up to how many terms do we have to find out? Because the series, the progression that is given to us, the sequence, geometric progression that is given to us is an infinite series. Infinite series means, as we all know, it goes on. There is no limits to that, it will just carry on. So how do we find out the sum of a geometric progression whose terms are unlimited, infinite? So how do we do that? So for that, of course, we have a simple general formula. For that, we have a very simple general formula, that is the sum of an infinite geometric progression with first term as a, yes, and common ratio r, where of course the condition is the value of the common ratio should be of course less than 1. It should be less than 1, and if this is also satisfied, then it is given by s, or s, we can just write s infinity, sum of infinite terms. Nothing, but it's a very small formula. That's why I was telling you today is going to be a very short video, small video. So please, yes, I know you are very patient, so let's finish this at the earliest. A by 1 minus r. So alright, that's done, I guess. So let's begin with the exercise. So you can pick up, I believe all of you have your pen, paper, textbook, notebook, everything. So get ready, keep it on the table, the textbook wide open. Shall we begin? Let's begin. So the first question, as the question reads in general, find the sum to infinity in each of the following geometric progressions. So the first one is question number 1, that's 1 by 3, 1 by 9, and so on. So here, the first term is 1. The common ratio is 1 by 3. Okay, 1 by 3 upon 1, that's like 1 by 3. So definitely this is like less than 1. 1 by 3 is of course less than 1. So in that case, what will be the sum of infinite series for a geometric progression? A upon 1 minus r. This is a very easy exercise, okay? So let's finish it up. A is 1. 1 minus r value is 1 by 3. So that's going to be 1 minus 2 by 3. By taking LCM, 3 minus 1. So that's like 3 by 2. So that's going to be like 1.5. So this will be the sum of the infinite series, geometric series that is given to us. Geometric progression, 1.5. Then pick up number 2, those who are done. 6, 1.2. 2.4, and so on. So what is the first term and what is the common ratio here? What is the first term and what is the common ratio? The first term is 6, okay. Common ratio, 1.2 divided by 6. That's like 12 divided by 60, so 12 ones are 12, 12 fives are 60, so that is again less than 1. So it's 1 by 5, which is of course less than 1. I believe you are doing your preparations well enough. As I always say, please do enjoy the struggle, okay? Because you're going to miss this day. School days are the best days. Because once the schooling is done, education is done, then actually starts the struggle period. You have to start for a job, you will start running a family, responsibilities grow. Actually enjoy your life as a student. So enjoy the studies, enjoy your friends, keep everything balanced. Then life becomes very interesting. But yes, during examination time, yes, upay nahi hai. We have to study, we have to struggle. So struggle, something good will come out from it. Okay, so here also just applying the formula. A value is 6, 1 minus R value is 1 by 5. So that's like 6, 5 minus 1, 4 upon 5. So like 6 5s are 30 by 4. So that's going to be 4 7s are 28 to the left. Alright, the value is now 7.5. I think it will not take half an hour also. Today's class is very easy. Let's go to question number 3. Those who are done. Tomorrow is a weekend, so definitely I'm very sure that most of you must be waiting to finish the classes so that you can go and watch some movies or do something or rest. Yes, you should. I'm also going to do that. So here the first term is 5. Common ratio, let's find out. Common ratio is 20 upon 7 divided by 5. So that's like 20 by 7 into 5. 5 ones are 5, 5 fours are 20. So 4 by 7. Yeah, this is also less than 1. 4 by 7, so that's also less than 1. So again, sum to infinite terms of this geometric progression will be first term A, 5, common ratio 4 by 7. So that's like 5 by, I'll show you this one, 7 minus 4, LCM is 7. That's like 5 by 3 upon 7. So it's 5 into 7 by 3. So 35 by 3. That's it. That's the solution to that. Question number 4. Minus 3 by 4, 3 by 16, minus 3 by 64, and so on. So the first term is minus 3 by 4, common ratio 3 by 6. So, sum to infinite terms, that is minus 3 by 4 divided by 1 minus R value, again is minus 1 by 4. Let's solve this. Minus 3 by 4 divided by 1 plus 1 by 4. So that's like minus 3 by 4 divided by 4 plus 1, 5 divided by 4. 4 cancels. We have the value as minus 3 by 5. So that's it. The first 4 questions done very swiftly because, as I said, it's not a very huge topic. It's a very simple topic. Of course, before we know it's always difficult. After we know it's always easy, isn't it? Yeah, that everybody knows. Bye. Chalo, chalo. Let's go to number 5. Question number 5. Prove that. Prove that 3 1 by 2, 3 power 1 by 2 into 3 power 1 by 4 into 3 power 1 by 8 into dot dot dot. This value is 3. Okay, so how do we do that? As I always say, don't go for the looks. Looks can be very deceptive. Never judge a book by its cover. That's why you should never judge a person by what somebody tells of that person. Also, similarly, mathematics also never judge a problem just by its looks. Some problems might look, wow, very deadly and all. No, try to solve it. It's very easy. Let's see what happens here also. The left hand side. 3, 1 by 2, 1 by 4, 1 by 8. Alright, so what we can do here is 3 common. So all the powers, exponents we can add, isn't it? These are basic things. 1 by 4 plus 1 by 8 plus dot dot dot. So this also becomes infinite because there is no limits given. It goes on till infinity. So let it be as it is. Now we will apply here the sum of infinite series of a geometric progression. So here now maybe we will do it here in the rough. Otherwise it might look very messy here. Right. What will be the first term here? First term is 1 by 2. What will be the common ratio? Common ratio is 1 by 4 divided by 1 by 2. So that's like 1 by 4 into 2 by 1. So common ratio is 1 by 2 less than 1. So here this sum of infinite series. Definitely common ratio is 1 by 2. That will be common for all. So that's going to be A. What is A? 1 by 2 divided by 1 minus R. What is the value of R? Again 1 by 2. So that's going to be 3 power 1 by 2 divided by 1 minus half. That is half. So half you cancel. What do we have? 3 power 1. And what is that? 3. So that is our proof. So that's why it's very simple. So those who have finished, you can prepare yourself with the last set of questions. Question number 6. Now question number 6, what do we have there? Let x equal to 1 plus a square plus dot dot dot. Okay, that's x. And I'll just do it here. And y is equal to 1 plus b square plus dot dot dot. Infinite. So then, with this information, where of course a value and the value of b, it's given that it is less than 1. Fine, that's understood. With this information that they have given, you are supposed to prove that 1 plus ab plus a square plus b square infinite is equal to xy divided by x plus y minus 1. Okay, we'll get back to that. Let's see what information can we derive out from the informations that is given to us by the question. See, this is an infinite series, and I think common ratio is there because a by 1 is a square by a is a. So this is a geometric progression, infinite geometric progression. So that will be x equals to, so here, what is the first term? First term I'll just denote by a. First term is 1. Common ratio is a upon 1, that's a. And it is given that the value of a is less than 1. So in that case, we can use the sum of infinite series here. So this whole term, since it is added, no? Plus addition, so that's sum. That will be simply a by 1 minus r. So x is equal to, what is the value of a here? 1, first term. 1 minus common ratio is a. Alright. This is the info that we have from the given question. So we will let it be as it is. Similarly, if we go to the next question, next condition, what do we have? Y is equal to, likewise, what is the first term there also? It is 1. Common ratio, of course, b. That is also given in the question that it is less than 1. So in that case, Here also, okay, let me try in the same way. So that's like a equal to 1 by 1 minus b. Let this be equation number 2. Alright, so that is equation number 2. Alright, so these are the informations that we can get from the given informations. Now going for the proof. Let's start with the right hand side. So this is a very different question, and you're going to learn something very different and new from this question, which I'm going to give you very soon now. So the right hand side is xy, that is x into y divided by x plus y minus 1. So that value is going to be, let's substitute the values of x and y. What did you get the value of x here? 1 by 1 minus a. 1 by 1 minus a into y value 1 by 1 minus b minus 1. So these informations are already used. We don't need that anymore. I hope so. Now, if we can do a little bit of simplification, product. Okay, I'll just write 1 by 1 minus a multiplication, so it's like 1 minus b. Here, common LCM, 1 minus a, 1 minus b. So here we have 1 minus a, so we'll have 1 minus b plus, okay, I'll use brackets. Here 1 minus a minus 1 minus a, 1 minus b. Common LCM, okay, and the common denominator gayab. So then we have 1 by 1 minus b plus 1 minus a minus 1 minus b minus a plus ab. So that's going to be 1 by 2 minus b minus a minus 1 plus b plus a minus ab. So we have minus b plus b minus a plus a. So then finally, time to learn something new here. So that's going to be 2 minus 1 is 1 minus AB. And that means AB means power 1, whole power minus 1. From here we can get the proof directly. Okay, but unfortunately, but don't worry, when time comes, definitely I will bring out a video on that particular chapter also. Unfortunately, with the reduced syllabus for this batch, the chapter of binomial theorem has been reduced, has been removed. So that is some concept which is going to leave, that is a gap that we will have. So in the future, when you get time, please try to, I'll also bring out the videos very soon. So in the future, try to get some time out to learn this topic of binomial theorem, binomial expansion. It is very important. So now, of course, I'll just give you what happens. I'll just give you the formula, I'll just give you the theorem. We'll be applying that directly. But yes, maybe in the days to come, I'll be bringing out a video on binomial theorem. So please go through that theorem, that chapter also. It's very important. Even though it is reduced, maybe not for the examination point of view, but for the knowledge, and you see, we need that here. So now as per the binomial theorem, for this expansion we have, you can keep a note of this, okay, that's like 1 minus x whole power minus 1. Maybe in physics and chemistry, in some topics you must have come across this. 1 plus x, 1 minus x whole power minus 1. This expansion with from the concept of binomial theorem is nothing but 1 plus x squared plus x cubed plus dot 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 up to infinity. Okay, and similarly 1 plus x whole power minus 1 one that also you might need, I'm just giving it to you, will be 1 minus x plus x squared minus x cubed plus dot 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 minus 1 whole power r x power r dot 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 up to infinity. That goes on like that alternatively, minus plus minus plus minus plus, it goes on. Alright, so yeah, now of course you might be slightly surprised that okay, what is going on here? But as I say, this is from a topic called binomial theorem, which has been reduced. But as promised, I'll be giving out videos on this very soon. Do watch those videos where you will learn these topics concerned. Okay. So for now, let's stick to this. So here we will be needing this particular formula. This one. Okay. So this we can expand to be 1 plus x square plus x cube plus dot 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 up to infinity. So that's like 1 plus ab plus a square b square plus a cube b cube plus a power 4 5 6 7 8 9 10, and that is the proof that has been demanded in the question. That's 1 plus ab plus a square b square plus dot 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 means okay, a cube b cube a power 4 b power 4, it goes on like that. Alright, so yes, that winds up this exercise 9.4. So there are not many questions, as I told you. So as I said before, it's not going to take a lot of time. So this is the end of the chapter for now. With respect to the reduced syllabus, there are some exercises on sum to n terms of special series also. So okay, some other time, yeah, we'll have to do it some other time. But there is something that I think you need to know. Okay, so listen. I'm going to give you that. You can take a note of that, because of course in mathematics we might need also, and in physics and all other terms we need. So that's like some special notes. Because I know that most of you will not come back and then go through the left out topics again. So let me just give you right away, right now, that is the sum of the first n natural numbers, 1, 2, 3, dot, 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 plus n. Sum of the first n natural numbers. These are done with this special series, okay? Sum of the first n natural numbers is n into n plus 1 divided by 2. This is number 1, special notes. Sum of the first n series. Sum of the first n natural numbers. Sum of the first n natural numbers is given by n into n plus 1 divided by 2. You can apply that in different concepts, where n, if it is limited, yes, you can just add that. Okay. 2 is sum of the squares of the first n natural numbers. So if you come across like this, there are certain topics where we use this directly. Sum of the squares of the first n natural numbers. So that will be n into n plus 1. This is a summarized formula. 2n plus 1 divided by 6. There is a proof to this. We solve and all. We're not going to do that here now. Maybe see in some other videos where you can when you get time, you can come back and just watch. So n into n plus 1 into 2n plus 1 divided by 6. We also have for sum of the cubes of the first n natural numbers. Sum of the cubes of the first n natural numbers, and that is given by n into n. So these are some special series that will be good for you to know. Okay. Alright then. So that winds up the chapter for this. The sequence and series with respect to the present syllabus. So next up, we'll have to pick. Next up, most probably we will start with the conic sections, I guess. Next topic, yeah, most probably we will start with conic sections, because that's also one interesting topic there. And it's very good for your examination point of view also. It gives you some very good marks also. So next topic that we will do is the conic sections. We have the circles, we have the ellipse for this reduced syllabus. We do have the parabola and the hyperbola, but not with respect to this present syllabus or present batch. So we will be trying to do that very soon. Okay. So alright then. Thank you all for tuning in to learn. I thank again once each and every one of you. Okay, and then yes, I do have a request to make tonight. Yes, if you still haven't subscribed, please do subscribe also. Okay, please, and then kindly share also about this channel, so that, because there are many other students also who don't even have a source to learn. There are no tuitions, especially in the outskirt areas and all. They don't have any tuitions. There are no sources to learn also. So please do share with them. Okay, please do share with them. Let them know about this channel, that maths is being taught for free, no tuition fees, nothing, because there are many poor families also. So I would request, within your capacity, please do share about this channel, about this knowledge. Let them also learn for free. Let them also learn for free. Okay, so please do subscribe and share this channel with everyone. So thank you each and every one of you. Intisana, um, Imlimern, some of the names that I can recall here. Bindang, Chuba Jungla. Okay, all of you have some nicknames. So the other names, of course, I'll try. What, Ashley Devery, Afterlife. Okay, Lance Longomer. All right, Chuba Manla. Fine, Men. Fine. Yeah. Good night to each and every one of you. Yeah, Rongsen Pongan. Okay. Good night. Good night. Thank you each and every one of you. So yeah, I'm going to read all the nicknames also. So I think that's done. All right then. Okay, so it was good reading all the nicknames. All right then. Thank you. Good night, each and every one of you. See you with the next class, with the next topic, with a very fresh topic. Study well, my dear students, and stay safe. Bye bye. Okay, I'm back again. Sir, I feel this concept has something to do with limits or integration. Mm, in mathematics, of course, yeah, I can give you some time. Those who have some doubts, you can just clarify that also. We have some time tonight, not much, but okay, 5 minutes. I feel that this concept has something to do with limits or integration. See, every mathematics topic is interconnected in one way or the other, but not on the surface level, not exactly so. These are very independent topics, also, yes, but definitely every mathematics topic is interconnected, interlinked with each other in one way or the other, but not as of now. Okay, sequence and series, not as of now, but yes, we will come to it very soon. So, not exactly. Okay. If anyone has any other queries, you can just let you can just share your thoughts also. If any one of you have any doubts regarding anything, I can give you 5 minutes. 5 minutes is not going to cost me anything. Okay, all right then. I guess at least for tonight you don't have too many doubts. So, all right then, we'll wind up here. See you. Good night. Good night, every one of you. Bye bye. Take care. Stay safe. Awkward moment of silence in the classroom. Yeah, I also miss the classes. I also do miss the classes. I hope very soon we'll be resuming at least some part of the normal classes. So, yeah, that was slightly a moment of classroom feeling. Hopefully, we will meet each other very soon. So, that's why please study well, work hard. We will also try our level best. So, study well, work hard so that we can all meet each other in the classroom and then we can have a happy learning also. Okay? So, all right then. Bye bye. Good night.